Hi Christoph! I love using Cloud Functions on Google Cloud, but debugging is a lot easier on my local laptop.
Hi Martin! Then let me show you how to develop and debug your Cloud Functions on your local machine.
Thanks for joining me today, Christoph. What do you do for a living?
I'm a strategic cloud engineer at Google, based in Munich. I help customers develop their workloads specifically for the cloud.
So you must have heard from customers who want to debug their Cloud Functions on their local machine, right?
Yes, that's a common question. If you want, let's do it right now and I will show you how you can do it.
But I don't have all of Google Cloud here on my local laptop. How could I debug code that is meant to run on top of Google Cloud?
Well, Google is committed to be the most open cloud. We open source a lot. So you can actually run small parts of Google Cloud on your laptop. For example, the framework around your code in Cloud Functions is called the Functions Framework. And it was fully open sourced. So you can use it on your own machine and run Cloud Functions on top of it. It is not an emulator. It is the exact same code Google is using for its Cloud Functions service in production.
All right, so how do I get the Functions framework?
You can install it with your language specific package manager. This is what it looks like in Node. Just run npm install Google Cloud Functions Framework. There's a function framework for each language we support, like Go, Java, Python, PHP, Ruby, and .NET.
Nice.
Now that we have installed the framework, let's debug a function on my local machine. Here is an example. When you upload an image to your cloud storage bucket, this particular cloud function identifies what's in the image using the Vision API and write that metadata back to a database.
That's a lot happening in a single function.
Let's start simple. We will run a function triggered by an uploaded file and store back the name to Firestore. By executing the following command, we start the function framework locally and point to the function handler. We now expose the cloud function on localhost port 8080.
Cool. Now, how do you call that function so it actually runs?
To invoke this event-based function, you can use a single curl command towards the localhost endpoint. There's a particular comment holding an event arc event for an image uploaded to a cloud storage bucket. To form payloads for other event arc events, like in Cloud Audit Log, you can look up the link docs in the description of this video. It will guide you how to create payloads for other events.
All right. What happens when it runs?
Let's run it then. The image, which is referred to in the event payload, actually exists in my bucket. So my local function can pick it up. Here you can view it in the cloud storage bucket. And if we check the Firestore database now, we see that the uploaded file name was added by my local function.
Got it. But the Firestore database isn't running on your local machine, is it?
That's right. Cloud Firestore runs in the cloud. We are not using an emulator here. It is a remote API call made by a client library in our function, here in the code. It is using my personal account credentials to do that call.
But when your function runs up in the cloud, it will run as a service account and not as your personal account, right?
That's right. I ran gcloud auth application default login before. That means the API call to Firestore will use my account. When my code has been deployed to the cloud, it will run under this particular service account instead of mine. Let's use this service account when we are testing the function on my local machine. That way, we can reduce the risk of access problems after we have deployed it. We can impersonate this particular service account by running the following command: gcloud auth application default login impersonate service account flag, and then add the service account we actually want to use locally.
Got it. And your code worked before doing this, so impersonation is an optional step?
It is. It is an optional step. I could keep my personal credentials when testing locally, but this way I'm testing the service account privileges and roles based by the deployed function.
Right. We'd like our dev environment to be as similar as possible to the production environment, right?
I agree. So for the next step, let's add the call to the Vision API now. Currently, our function is only saving the name of the uploaded image file. We would like to store the objects visible in the image instead. For example, if someone uploads this picture, we would like to write to the database that there's a cat in this particular image. Let me enter the code calling the Vision API and extracting this information. First, add the Vision API client. Use it for detecting labels and grab the annotations from the response.
Right. The Vision API is very useful for this sort of thing. It's good at picking out objects and images, as you said. But it returns a pretty complex data structure, if I remember correctly.
Yes. I also never remember the exact structure. Let me add a breakpoint in Visual Studio Code, and then we can look at it and find out the exact structure. Now I will run my function using the VS Code integrated debugger. I have that command as a script in my package.json. Now that the breakpoint is there, I will invoke the code again with the curl command. It will stop at the breakpoint, and we can inspect the current variable assignment. And here is the response, returned by the Vision API. Now that I can see the structure, I can rewrite the code to extract only the object labels in the picture instead of the full blown up object. Let's invoke and test those changes again. I will run the curl command for that once more. Then let's open Firestore and check. Here it is. We can see the image name as the key and a set of labels extracted by the Vision API.
And I noticed that you didn't have to restart your code to run the new version. How does that work?
I used nodemon. It restarts whenever it detects a file has changed.
Nice. I really like hot reloading.
Me too. Many of our customers actually, they use TypeScript instead of Node.js. We have to add a few things to get hot reloading working for TypeScript. We need to watch for changes, compile the TypeScript files, and restart the function framework. But this is fully possible.
And all this code is available on GitHub?
Yes. The full TypeScript example is available on GitHub. Let's add the link to the show notes here. You will see that also you can use remote stored secrets from Secret Manager and inject them as an environment variable in your local development setup, in this example stored on GitHub. I have all written up this and other best practices in a blog post.
Excellent. I will add the link to your blog post too. Thanks for showing us this, Christoph.
It's a pleasure.
And thank you everyone for watching. If you have questions for Christoph or me, please add them in the comments. Also, let me know if there are other serverless topics you'd like to see in future episodes. I read every single comment. Until next time.